Hello, everyone. Thank you for coming to my talk. My name is Tomasz, and I'm from Virtus Lab. And first off, what do I do? So I do a bunch of things. I maintain a lot of different tooling-related open source tools. That includes Metals, which is the LSP server for Scala. Also, I maintain Bloop, which is the build server, also for Scala and Java. I maintain Scala Meta, which is basically two things, the parser and SemanticDB, which is this protobuf format that allows you to store information about your code there. I also take care of AIM-Unit as much as I can, probably less than the other tools, which is one of, I think, simpler testing libraries for Scala. I work on MDoc, which is this markdown compilation thing, so you can type check your markdown using MDoc. And last of those tools, open source tools, is the actual Scala-free compiler, the presentation compiler part. I also work on the Scala-free LTS versions, so I backport things and I try to release them. We'll get a new RC version for 3.3.7 next week. I didn't have time to do it before, but everything is mostly ready. So if you use the nightlies, you can actually test how that will look like. I am also part of the Scala core team, where I try to help coordinating all the efforts around it. And we mostly have technical discussions there, but sometimes less technical ones, and we make some decisions about the Scala community and the ecosystem. And last but not the least, I'm also part of the moderation team. So if you have questions about that, you can catch me later. All right, so a brief poll. So the first question was supposed to be this one, but I got just asked, who actually uses Emacs with Metals? So, all right, 4 people. That's still a percentage, yes. All right, who has used Metals at all? Okay, cool. Did you ever have issues with that? All right, so it's around the same amount of people. Did you report those issues? I understand why you didn't report them, because figuring out what is wrong with your tooling is actually kind of hard, and there's a gap between what I and other maintainers know and what a user who just wants to get their stuff done is able to know, and able to how much effort they are able to put into figuring out what is wrong. Because of that, I'll try to briefly at the start go over what kind of what are the ways of figuring out what Metals tells you, why it is not working, or maybe why there are some errors. So I'll go briefly over that. I'll try to explain a bit more about BSP and what that is, and the build servers, how that connects to build tools. Then I'll go over some features that I think people might not be aware of. And lastly, I'll tell you a bit about our efforts to make the AI world friendlier for the Scala people. Let's start with Metals issues. So if you ever use Metals, for example, in VS Code, unfortunately, I don't think that will be available in Emacs soon. But there's these 2 statuses we have at the bottom. First one, it tells you what build server you are connected to, and if there are any errors reported by the build server. Here I have Bloop, and I have this. Those are not actual errors. This is just for the presentation. The second status is the status of the presentation compiler, meaning are there any errors reported happening inside that presentation compiler, and whether we actually know what module we are in. So here we are in the Metals module, and there were some 13 reports generated by the presentation compiler. You can find those reports in the .metals reports directory. So anything you see on those statuses, you can actually see there. If you want to dig in maybe what's going on behind the scenes, you can take a look at the metals log there next to the reports directory. If you're interested, so that might be also important for anybody trying out some custom editors. If you're interested in what is happening, how does the exchange between metals and the editor works, you can create the LSP trace JSON, and then we will, you need to reload metals, but then we'll be able to send all that communication into that file, so you can easily see, you can even tail on that and see what's going on. There's a lot going on, but you can also dig in later. We have similar trace files for all the protocols we use, and I think we use 4. We use the LSP, which is the language server protocol. We have the MCP, a new thing, I'll get back to it. We have BSP, also, we'll get back to it. And we also have DAP protocol. I will not get back to it because I don't have time for that. But you can take a look at those if you're interested. If you want to do hardcore debugging, and if you have time, you can turn on the debug mode in Metals in the server properties, or if you're running via some different means, you just have to add it as a property to how you are running the Metals binary. You can get more stats with the statistics all, which can give you information maybe what parts of indexing are taking a longer while. And if you have any issues with compilation, then you can turn on the variables compilation that currently works with Bloop. I think I can make it work with SBT, but I haven't looked into that. And why is it hardcore debugging? Because you get all that information, so that's a lot of information. But it might be helpful for anybody who knows about it. You don't have to look into that, it's just very hard to figure out, but I usually spend a bunch of time looking into that when there's something happening, so you just send it to me if you're able. But obviously, a lot of the times you just want to make things work for you. So I did this helpful diagram, I hope. What can you do if things are not working? So first of all, you can try clean compile if the compilation seems wrong. Another thing you can try if that didn't work, you can try to reconnect to the build server. There's a command for that, and there's also one in the Metals tab if you're using VS Code or anything that provides you with the tree view. I think NeoVim also does that. If that doesn't work, you can try restarting your build server, which might be Bloop. There's also a command for that. You might want to clean any mutable state that Metals has with reloading window. And last thing you can try out is clearing out your .bloop if you're using Bloop, or just cleaning everything you can. But honestly, that happens very rarely for me. If it does happen, or any of those things happen, if you have any time at all, please report that. Because if people report things, we actually fix them. So that's pretty great. We recently, for example, fixed an issue with release flag for 2.13. I did two different fixes. One didn't work fully yet. Then I had to do a very terrible reflection, which I will not tell Lucas about. We also found that there's an issue with 2.12 because the collection were a bit different. We weren't using 2.12, and there was a lazy collection somewhere, which wasn't lazy in 2.13. And we had concurrent access to the presentation compiler, which was terrible because the presentation compiler really just works with one thread. We also managed to fix a lot of Scala-free presentation compilers things, not just, although you can argue that some of the issues happening in Metals sometimes could be actual compiler issues, but mostly they are presentation compiler, which is this part of the compiler I am working on. And with 3.7.2, we actually managed to make the completions much faster when you're using a lot of exports. It turned out with exports, we were trying, when showing completion, we were trying to dig into all the trees for those exports, which was quite terrible. And if you're at any point interested in contributing or learning more about tooling, we are doing the online Scala tooling spree. We try to do it every 3 weeks, but that was supposed to be today, and I really don't have time to work on it today. So hopefully next week or the week afterwards, we announce it on different channels, on Scala Space, Twitter /Blue Sky /Mastodon profile, or also on Discord. All right, that's it about the issues. Another thing a lot of people don't seem to understand fully is what are the build servers, how we connect to that, what are the possibilities there. So currently the default build server for most things, there's an asterisk here, which I didn't add, but you understand why the asterisk. Bloop is used because you can basically run a single server in the entire machine and have everything compiled on that. So that is pretty safe in terms of RAM usage, especially if you have a lot of different workspaces. I sometimes have 10 or more. You don't want to have a separate server for that. It can concurrently execute multiple tasks, and we heavily use it in Metals for almost all our tests, so we are confident about it the most. However, it might sometimes be problematic. For example, in the Scala free compiler, you should actually use SBT as your build server, and you can do that with the switch build server command. You can also do that if you feel like maybe there's errors stemming from the compilation that shouldn't be there. So you can try switching, see if that works better for you. You have to be mindful that if you use SBT build server, you should then from the command line also connect it to it via ---- client option or use SBTN. Otherwise, I think it will start another server, which is terrible because you don't want to. If you switch at any point, it might actually recompile your whole workspace. So you have to make sure that you're not actually, on a deadline or something. What about mail? So I think mail presentation a bit later, but I don't know if Li Haoyi will mention that, but with 1.0.0 version, there's no longer a bloop. Before that, there was an option to choose either bloop or BSP. Now it's only BSP with 1.0. The previous versions, you can do the same thing like with SBT. If something is not working one way, then switch to the other build server. I think this is done because it's harder for them to support both ways, and both ways were actually in mail. If you find any issues, you should probably report them to the mail repository, but mention me if it's related to anything build server related. For Gradle and Maven, we don't have anything else aside from Bloop. We generate the Bloop configuration, which is a bit separate from special plugins that we publish. There is actually a Gradle BSP by Microsoft, but that is actually used only for build server errors, build definition errors. So if you have something broken in your build Gradle file or build Gradle KTS file. What about Bazel? So Bazel is another thing altogether. There's a couple of things happening. First of all, Bazel is super complicated, so there were some tries, at least for me, super complicated. There were some tries to export configuration from Bazel to Bloop, but this didn't make a lot of sense. The way to use Metals with Bazel is currently Bazel BSP, and that will be done for you automatically. We piggybacked on the efforts of the JetBrains team, but they actually switched to another approach now, so we had to fork that, and you will see Bazel BSP under the Virtus Lab organization. So if you have any issues with that, I'll probably be working on making sure that works better. Or I'm really happy to accept help, especially if you know Bazel. Piotr ordered me to also mention Scala CLI, which is not really a build tool, but is it? So it actually underneath it uses Bloop. So it connects via BSP to Scala CLI, which has this small server that then compiles using Bloop. So that's a bit complicated, but it works. And in Metals, it's the default thing we use for situations where there is no actual build definition in the workspace. So if you create one single file like main.scala, it will start Scala CLI. Even if you don't have it installed, then we'll start it from a jar. And later there will be, after the lunch, Piotr Habelski will explain all the possibilities of Scala CLI that there are. So this is the summary of everything that Metals supports. Not everything. There's also Bleep. There's custom build tools from companies. So there's actually a lot. But for the things that I try to maintain, that's mostly it. It's not perfect, but you can see there's a bit of complexity here. Okay, let's move to some features. So one feature that I think people might not actually notice that much is this Metals Sub tree view, where you can see the actual structure of the code, not the file structure, but the actual structure, packages, and everything. You can look into your dependencies. When you go to definition, like for example, here I went to the future definition of future, and then I used this 4 hours button on the top. It's not that easy to spot, but it is there next to the collapse all button, and it tries to find the exact spot within the whole structure, even if you have a lot of different libraries, and so that you can explore a bit around that, see what's going on there. Maybe there's an interesting class next to it. The tree view will also have all the commands that I mentioned previously. So if you don't know how to use the commands from the command palette, I also suggest finding how to use the command palette in VS Code, in all the clones, because that's very useful. Oh no, this, yeah. Another thing that I find when I'm coding very useful is worksheets. Anything ending with .worksheet.sc will be evaluated in Metals. We now also support using directives. I think 5 different using directives. If you use Scala CLI, they have the same, but much, much more. So you can basically create your own worksheet and then run it with Scala CLI currently. That should work. But the most useful way I find worksheets are just creating a worksheet using the special command to just create worksheets in the current module. And then you have access to the whole class path of everything around that. So you can, like for example, here you can see that I actually created it inside tests. And I could get the information from the build info plugin, see what are the Scala versions there, and then that got evaluated and shown in those inlay hints on the right. We actually switched to inlay hints recently, half a year ago, I think, from using our custom decoration protocol, because if we use custom extensions, we need to actually implement them on the client side, so every editor. And there's a lot of editors nowadays, so we don't want to do that, so we use inlay hints. And inlay hints are also used for a number of other issues. So we have around 8 ways of showing you some additional information about the structure of your code. The first one, you've seen it if you've been to the previous presentation. It will be the type inferred by the compiler when you don't provide it. We will also show you implicits or givens or usings that are being used in your code. We will try to show implicit classes. We don't show extension methods because I'm not sure how to show it yet. I have to figure that out. We can also show you type parameters if they're inferred, if they're not specified by you. We can show you types in matches, by-name parameters. So if there's a by-name parameter being used in your code, you will see that if you turn that on. And not really last, but last on those 2 slides, named parameters, which will show the name of the parameter if it's not specified by you. That works together with by-name parameters, although it looks a bit weird, but there's no better way to do that. And all those inlay hints, each one of them has a toggle command. So you can actually bound that to any specific key binding you have and quickly turn it on and off. It's useful because you don't want to actually always go to the settings and change it and go back. Sometimes you just want some additional information at some point, but then you don't want to have the code polluted with all that additional information. So it's useful to know those toggle commands exist. You can also invoke them via the command palette. And there's also a new X-ray mode, which is the same thing that is in IntelliJ, that was implemented recently by a contributor. It's only for Scala 2 because the contributor did it only for Scala 2. I will be porting it for Scala 3 or my colleague. But essentially, it shows you if you have a chain of invocations, it will show you intermediate types inside those chains. So this is exactly the same thing IntelliJ does. I hope it is not copyrighted because I named it X-ray node. Yeah, I'll ask Maciej later. Yeah. Another thing that is useful, especially if you need to test something quickly, is the new project command. So if you are aware of the SBT new command, that is exactly the same thing, but a bit more UI-centric. You will be shown some curated example templates that you can actually start. You can write a custom one if it's not there. And we will try, if you click on Discover More, we will try to download all the possible templates that are available on the Gitter 8 wiki page. I don't know if it's very much updated. I think I also might need to update a bit all the curated ones. But it's very useful, especially if you just need to create something quickly. And another thing that I find especially useful, if you've been to the talk by Anton Sviridov yesterday, you have seen how highlighting can be done syntactically. It can be done through tree-sitter, or it can be done with the regexes, but all of that is actually not that useful if you want to know semantic information about your code. So if you want to know if something is an object, a class, a trait, or just a value, you will not know that. All those syntactic highlighters actually base the assumption that if you have a class, it needs to be uppercase. If you create a lowercase class, it will not know it's a class. So you are able to turn on semantic highlighting. I don't know if that's by default, but there's a setting for VS Code and all the other editors. They should have a very similar one. And the big thing that you can do with semantic highlighting, you can actually customize it. I actually added a rule to create a strike through for any deprecated symbols, which is very useful because you see them at first glance. And you can change vars to be red so that you know that there's something fishy going on. So vars will be red. You can still use the vars, but you know where they are if it's red. And semantic highlighting actually allowed us to create SQL highlighting for string literals. So you can see if you use the SQL or capitalized SQL, and there's one other one that I forgot, interpolators, you will see this a bit better because it will actually show you how the SQL would be highlighted. So I think that's pretty useful. It might not work because it's also contributed by the outside contributor, but the code looks really nice, so we might be able to quickly fix that if it's not working. And last of the feature I wanted to mention, this is only in VS Code, I think, but it's the Test Explorer. So there's an additional tab called, I think it's called Tests, and we'll populate that with all the tests from your workspace, so you can see that. You can easily search for names or specific tests. You can run any subtree of those tests, and you can even go to definition of that test, so quickly find what you're looking for. And we support multiple frameworks, suites, and people also are adding additional support for different new things. And this is how it looks like. This is from Metals. I broke something, and it's showing it red. I cannot go into details, but I find recently actually I have been using it much more than previously because it's so easy to find tests and launch them. You don't have to go to the file and do that. Okay, so my last part is about MCP, so Model Context Protocol. Why am I talking about MCP? So there's a lot of tools that are being created. Basically, most of them are clones of VS Code, not all of them, and all of them are LSP compatible. This is not, Metals is the only thing that can provide support for Scala for those editors. Claude here is not really an editor, but I also mentioned it because it's a nice thing to use. And Metals will support Scala there, But, if you're using LLMs, they hallucinate a lot. So it's a bit problematic. So you get Scala supported, but on the other hand, it's a bit messy. So because of that, we decided to implement model context protocol support in Metals. So this means that we provide, it is very similar to the other protocols. It uses JSON and just sends back and forth information. But this time it's between the agents which can invoke a tool. It can do a number of things, but basically the main purpose here is either to make sure they hallucinate less because they can get the actual information Metals knows about the code base, or able to verify things by running tests or compilations. And it is much better to use that than not to use that when you're dealing with LLMs. There are three main things here that MCP supports. One of them is tools, which we use the most. It's basically invocation of something or getting some information. I think Maciej yesterday said it's basically a function. There's also resources. Resources are more static content. It doesn't really have to be static. It's just, you can actually send back whatever you want. There's also the third thing called prompts. So if you think there's an actual better way of specifying prompts for Scala, you can provide it in Metals for people, and the LLMs might pick those prompts sometimes when the user has a very small prompt, or maybe it's very difficult. We haven't experimented a lot with prompts, so I am not 100% sure when it picks it up. You can always say, pick up that prompt, that works, but then you have to know about it. And setting up MCP is very easy. You just do metals.start MCP server to true. If you're using VS Code or Cursor, it will automatically create the configuration for you. If you're not using those editors, we will create .metals MCP JSON, which you can possibly copy for a lot of the other editors and try to use it this way. The configuration is very simple. You can see it's basically pointing at the local host, and this one is for Claude. For example, the difference between Claude and Cursor is that you need to add this type SSE, while in Cursor you don't have to do that. If you don't want to run Metals, you can still use that. There was actually a contributor that did a separate Metals standalone for example, if you're using, somebody did that. Somebody started IntelliJ, then had to a proxy that proxies to Metals. It's a bit over the top, but it's possible. Unfortunately, IntelliJ doesn't have the amount of tools that I think they should, which I'm convincing them that they should. The tools we have are formatting file, which I need to actually fix because it's currently sending the whole file back. It was contributed by another maintainer. I know why he contributed this way, but it pollutes the context of the LLMs very much, so we don't want to do that. We have compilation, which is very useful, testing. We can search for anything on the class path. We can inspect any signature. We can get any documentation of any symbol. We can import the build where the definition changed. We can also find dependencies. Mostly it's based on Cursor, Cursor, very similar, to use a prefix and maybe find a version, the last version or something. That's very useful if you're updating your project, and you can ask the LLM, update everything you can in this project, and that will be used. But how are those tools used? I said that the find dependencies is used in specific ways. Compile, test, import are often used when needed, but it's a bit of a trick it's a bit of an alchemy to make the LLMs actually use the tools. Compile and test are almost 100% guaranteed by most tools, by most LLMs to be used, agents. but other less, but I've seen the agents use all of the tools we have, so that's pretty good. And sometimes there were use cases I didn't expect they would use that for, so that's pretty good. But we still have to tinker with the descriptions and make sure that the description makes sense in terms of LLMs. What I found most useful in my workflow is using Cursor plus Claude, because Cursor has really great autocompletions that sometimes seem to actually predict what you are going to do, which is a bit scary, but it does it very well. And using Claude also very good. It has a lot of things that you need to do for coding with LLMs. It does it automatically. It doesn't do everything for you, but still it's very useful to use that inside your terminal, inside Cursor, because then Claude is able to infer that it's inside the Cursor, and it will show you all the changes it's providing inside Cursor, so it's quite nice to work. It works together. Of course, everybody has their own workflows and their own tools they want to use, but this is what I found very useful. And when you want to make sure that your tool actually uses MCP, you can add system prompt, or a rule for your tool to actually says, please use MCP, or maybe use a specific tool, like use formatter at the end, always. And that actually helps. Sometimes it has very unexpected situations when you're actually asking a question that doesn't necessarily need MCP, and it sometimes mentions MCP like randomly. So it's quite funny when that happens. And a new thing we did, a new tool, I merged it on Tuesday, is automatically generating and applying Scalafix rules on your code base. It's working for less complex situations very well. The more complex the situation, the more times it needs to work on it. But the idea here is that you don't really want LLMs to work on your entire code base. But if you have a specific need, a specific refactoring, you want a Scalafix rule. Scalafix rules are not that easy to get into, but we will create those for you. Even if they don't work, there will be a start for you. You can copy it over and retry it in another code base. I actually want to show that in a second. And yeah, I can actually show it. How much time do we have? Not much, not at all. I'm actually doing the, as I call it, no, 8 minutes, right? Ah, that's fine. That's fine. Oh. So this is, I created an example with a lot of deprecated methods. So it's an API, and I use the API here, all the deprecated things. So I'll start Claude, and I want it, hopefully that works, because with LLMs, you get, on live demos, you get the additional level of uncertainty. Okay, let's try. Generate a Scalafix rule to fix the deprecated usage of double. Okay, let's see. It worked every time I used it last time, but let's see. Okay. Okay, it's trying. Okay, this is a bit complicated, but what we are actually doing here is it's coming up with the implementation of the rule, and then we try to compile it. This will wait. Let's see. How does it work? Yeah, worked. So you can see that it actually changed the double to sum of two numbers, because we deprecated double, because that's two. And it actually created the Scalafix rule in here. And you can see it. It actually one-shotted that, so that's very good. Claude is good at that. It's a very simple rule, as you can see. If the more complicated the rule, it might iterate over it, because we'll try to return sensible errors for it. But for deprecated things, it worked pretty well. This is obviously a very simple situation. I will not attempt at the demo a more complex one, but in reality, yeah? No, it needs to compile. It needs to compile. It will try to fix the compilation, yeah. Oh yeah, it will start fixing the compilation maybe, I don't know. It's an alchemy. I would ask it to fix the compilation first, make sure it compiles. It will actually use the compile tool to check if there's errors. If there's error, try to fix them, and then you can ask it to generate the Scalafix rule. What we do here, this is actually, you can copy that over to anywhere you want and keep that rule, publish it. The only thing you need to do here is Scala CLI publish local dot if you want to publish everything, and that will work. This is the whole setup for a Scalafix rule. So if you want to just start with a Scalafix rule, create one. It's also very useful. You can create your own sample code that you want to work with inside your smaller workspace and try that. There's a number of usages. We are still tinkering with it, wondering how to make it even more useful. But the base assumption, as I said, is that LLMs are really good at smaller tools, to create smaller tools. If you have to deal with the large context, it gets very quickly, either the context gets full or it gets too complicated for the LLM tools to do that. Okay, that worked. That's good. So, we have some future ideas. So one thing might be a bit crazy, but I figured out that we could create a plugin engine for Metals so that LLMs could generate plugins that would query some information from Metals, like deterministically. This is actually very simple to do. The difficult thing is what to provide to those LLMs and how to do, what information it might be useful for it. This way, it could create its own tools to provide itself some information. So it's a bit of a meta tooling, yeah, that's good. And we're doing Scala Meta, it all fits. We haven't done any prompts, we didn't add those, so if anybody has ideas for those, we can add those. And one thing that might actually be quite simple to do is adding resources, that each resource would be only activated if a certain library is being used. So, for example, if you use cat's effect, then we would, maybe that's a bit complicated example, ox is less complicated. We could add a small snippet explaining to the LLM how to use it, and that should make it much more efficient in generating the ox code. You can always do the context manually if you want, but we could provide that for you. And if my assumptions are correct, the LLM should query for that resource and use it. And there's actually people adding tools. So there's a person who added a tool that adds debugging. So, you know, breakpoints, stepping over, pausing, everything. So the agent should be able to actually debug your code interactively using the debugger and expression evaluator and everything. I haven't measured that because I don't know if that will make sense. It sounds cool. We'll see. It's still not compiling all the tests. I think the contributor is using it for their own purposes. But we'll see. We could also have it under option. We can merge it and have it under option for people to test it out. We don't want to provide too many tools because then that grows the context. LLMs become less useful the bigger the context, and especially if those tools are irrelevant to your current task. Okay, so this is the end, and thank you. You can. You can reach me on all those places. And do you have any questions?
Maybe we have time for one quick question.
This lunch. Does anybody really want to eat? No, go ahead. Go ahead.
So very quick question. Thank you for the presentation. You have a slide that say cursor plus Claude, because I remember Anthropic Cloud stopped the service to the cursor. So what do you mean here? Like, do you mean something else?
Yeah, maybe that's a bit confusing. So what I do, you can actually see it here. This is cursor, and I run Claude inside the terminal here. It automatically detects that it's inside the terminal of cursor, and it wants you to create, to install the extension for Claude, and it installs the Claude extension for you, so that Claude is actually able to show you changes here whenever it wants to make those changes. So this is not like, this all works because everything is basically VS Code. So they can release VS Code plugins, and they will work with all those AI-enabled editors. I found that very useful. I mean, Claude has me most efficient, and it managed to do a number of things which I would not expect it to be able to do. But you can also just use the chat inside cursor. You can switch the models. You can use anything you want. Really, as I said, it's a bit of an alchemy, what works for you in this current context, what is the model. It's a lot of tinkering and figuring it out for yourself. Thank you for the question.
Okay, thank you very much for the talk.